Okay guys, so let's look at number 6. Triangle ABC is graphed on the set of axes below. Graph and label A prime, B prime, C prime, which is the image of triangle ABC after a reflection of a reflection over x equals -1. So let's locate the line x equals -1. So I'm going to go on my x-axis, which is right here, and find -1, which is that point right there. And remember, I want to continue with a vertical line through x equals -1. From here, I'm going to take each vertice of my triangle and count the distance from the line of reflection. So 1, 2 units away. So I'm going to go 1, 2 in the opposite direction. That's my A prime. For B, I like to count the distance from A to B, since we know that under a rigid motion, which is that reflection, distance is preserved. So it's 1, 2, 3 units away. So from A prime, I'm going 1, 2, 3 units away. Or I could just count the distance from B to my line of reflection. Now I'm going to do the same from B to C. 1, 2, 3, 4. 1, 2, 3, 4. And I had to connect all my vertices. Since my original image was a triangle, my final image has to be a triangle. Okay, question 7. As graphed on the set of axes below, triangle A prime, B prime, C prime is the image of triangle ABC after a sequence of transformations. Part A, determine and state the sequence of transformations. So, A prime, B prime, C prime is your new image. And this one, ABC, is your old. So we need to go from this right triangle to the triangle on the left. So first, let's see the distance from C to C. So I want to say that it went down 3 units. So there was a translation down 3 units, which brings C here. It brings 1, 2, 3, B here. And then A is brought down 1, 2, 3 right here. So the next thing is to determine whether there was some sort of rotation or reflection. So I look at my orientation of the letters. I start at A here, and I'm going to go clockwise. A, my next letter would be B. So I'm going to start on my image. A, my next letter in a clockwise motion is C. Since the orientation of the letters is not preserved, we know that there was some sort of reflection. So I'm going to reflect it over the line that's in the middle. In this case, it's the y-axis. So after that translation down 3 units, then there was a reflection over the y-axis. You don't have to write in the same order as I did. You could have said reflection over the y-axis, then a translation down 3 units. Now let's look at the second part. Is triangle A prime, B prime, C prime congruent to triangle ABC? Use the properties of rigid motions to explain your answer. Yes. Triangle A prime, B prime, C prime is congruent to triangle ABC. The reason is that a translation and a reflection, so we're going to write a translation and a reflection are rigid motions which preserve angle measurement and side length. or you could write distance. Okay, question number 8. So 8 says, a regular decagon is rotated n degrees about its center, carrying the decagon onto itself. The value of n could be 1, 10 degrees, 2, 150, 3, 225, or 4, 252. So for this problem, we need to remember that the minimum angle of rotation is equal to 360 divided by the number of sides. So we have to go back to the problem and see which figure we're talking about. They said a decagon, which you guys should know, is 10 sides. So we're going to take 360 degrees, the amount of degrees in a regular polygon, and divide it by the number of sides in this case, which is 10. So the minimum angle is 36 degrees, so we know it can't be 1. So now we want to look at our choices and see if 150 is a multiple of 36. So we're going to take 150 divided by 36. And when we take 150 and divide it by 36, we get 4.16, which is not an even number, so that's not a multiple. So we'll move on to the next one. 225 divided by 36, which is 6.25. Again, not a whole number, can't be it. And then now we're going to take 252 divided by 36, and you're going to get 7. So 252 is a multiple of 36. That answer works. If you didn't want to do it out that way, you could literally start at 36. And my next multiple of 36 is 72. Add 36 more, which would mean a third rotation of 108. Add 36 more, 144. Just that way might take a little longer. Okay, number 9. So we have, given the theorem, the sum of the measures of the interior angle of a triangle is 180. Complete the proof for this theorem, filling in the missing reasons. The only thing that we're given in this is that it's a triangle called ABC. So in our statement, triangle ABC is given. The second thing that we want to come up with a reason for it is AC is parallel to BD. You should notice that BD is a dotted line that we had to draw in. And when we draw in a dotted line to make it parallel to another given line, we call that an auxiliary line. And the reason why we create that is so that we could form angles that we know, such as our alternate interior. Our second statement that we were given was the measure of angle 4 plus measure of angle 2 plus the measure of angle 5 is 180. So let's find 4, 2, and 5 in our picture. Angle 4 plus 2 plus 5 is 180. So let's look at what we know for that to be true. We know that 4, 2, and 5 all lie on a line. So the reason for the measure of 4, 2, and 5 equals 180 is because angles on a line sum to 180, or just add up to 180 degrees. Let's look at our next step. The measure of angle 1 is equal to the measure of angle 4. The measure of angle 3 is equal to the measure of angle 5. And how do we know that's true? Because we said that these two lines are parallel, and here's our transversal. So parallel lines cut by a transversal form congruent alternate interior angles. So alternate interior angles are congruent. And the last step is what we were trying to prove. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180 degrees. So let's look at our picture. We said that 4, 2, and 5 is 180, those straight lines. And we said 1 is congruent to 4, 5 is congruent to 3. So look at our markings. If we know these two are congruent, we could substitute in a number 1 there. If we know 3 and 5 are congruent, we could substitute a 3 in there. That's how we got the measure of angle 1, 2, and 3 is equal to 180, and the reason is by substitution. And the last one that we're looking at in this video is number 10. So as shown in the diagram below, AC bisects angle BAD. So let's mark that up. Angle BAD is getting bisected. And when we see that word bisect, we think cut in half. So we're going to mark up our picture that angle BAC is congruent to angle CAD. The next thing that we know is angle B is congruent to angle D, and we want to figure out which method could be used to prove triangle ABC is congruent to triangle ADC. So after I highlighted my two triangles, you guys should notice that there was an overlapping of a yellow highlighter and a green highlighter right here. So if CA is being shared in both sides, that side is reflexive. It's congruent to itself. So we have 3 pieces of information. Let's see if it works. We have angle, side, we have an angle, side, which is choice 2. Let's look at an example of what angle, side, angle would be. We would have our 2 angles with an included side. If you're using angle, side, angle, the side has to be in between our 2 congruent angles.